Hello and a very good day to our lecturer. My name is Punchun Phai with the matrix number AE190091 from Group 3 of Section 6. In my segment of the video, I shall be presenting by giving a brief explanation on the abstract, introduction, problem statement, and also objective of the group project. First, I shall be presenting the abstract part. So for abstract, the solar energy can help supplement the national electrical grid, or it can be by itself and create a location that is self-sufficient on electricity through solar energy alone and not connected to the power grid. This system can be labeled as an off-grid photovoltaic system where all the energy produced is stored and used on site at a predetermined location. We were tasked to prepare a proposal of such a system for a residential house unit belonging to a Mr. Ahmad Nisfu, and in the end we were able to create our proposal for a standalone off-grid photovoltaic system for Mr. Ahmad Nisfu's residential unit by using the manual approach and as well as the application of the BEV30303 software that encapsulated our adequate estimation of electrical usage of a normal residential house unit in Malaysia. Next, I shall proceed with the introduction. Renewable energy sources have become very popular in recent decades to help reduce humans' carbon footprint and a step towards the direction of saving our planet Earth. One of the renewable sources that is quite popular is solar energy, as we can take sunlight and convert it into electricity that can be used by us humans. Our country, Malaysia, being a tropical nation at the equator of the Earth, the sun shines on our country practically every single day with marginal differences, or maybe during the occasional rainy seasons or monsoon seasons that could block out the sun. Hence, using this to our advantage, solar energy can be a very useful and an efficient form of renewable energy where the technology is being implemented in our country. Solar energy can assist by supplementing the national electrical grid, or it can be by itself and create a location that is self-sufficient enough on electricity through solar energy alone, and not connected to the power grid as it does not need to rely on the grid for electricity. This system can be labeled as an off-grid photovoltaic system where all the energy produced is stored and used on site at a predetermined place or location. In this group project, we were given the task of creating a proposal of a standalone off-grid photovoltaic system that could power a residential house unit located at Taman Seri Pulai Perdana Johor Bahru, Johor, Malaysia, belonging to a gentleman by the name of Mr. Ahmad Nisfu. According to the group project that had been tasked to us, we were able to create the off-grid photovoltaic system for Mr. Ahmad Nisfu through two methods, which is writing down manually and also using the software application BEV30303. Writing down manually had given us a general idea on the system, while using the BEV30303 had given us more in-depth information and analysis about the system that we have created for Mr. Ahmad Nisfu. In addition to that, now I shall proceed with the problem statement. So for the problem statement, the problems or questions that we have faced in this group project is what makes a self-sufficient off-grid photovoltaic system that could work efficiently and properly, as we would need to consider multiple things and factors such as the average electricity usage of a normal Malaysian household. Other than that, how can we utilize the manual approach and BEV30303 software application to the fullest to make sure that the off-grid photovoltaic system proposal that we would manage to provide for Mr. Ahmad Nisfu's residential house is a well-rounded plan. Finally, on to my last part, which is the objective to our group project. There are several objectives in this group project in order to complete the assignment of creating or making a proposal of an off-grid photovoltaic system for Mr. Ahmad Nisfu. These objectives are, first, creating a well-rounded off-grid photovoltaic system proposal that encapsulates the average electrical usage by a normal household in Malaysia. And secondly, making sure the technicalities of the off-grid photovoltaic system are presented properly in our final report. I believe that is all from me. Thank you very much for watching my part of the video.
Good day to Doctor.
Thank you.
My name is Wang Weiqi. Next, I will continue the presentation for the explanation of designing off-grid photovoltaic system for Mr. Ahmad Nisfu residential house by using PVC software. In this designing, the PVC software, which is PVC 7.2, is used. And next, before we beginning for the designing of the off-grid photovoltaic system, And we will go into setting for the project design and also a standalone system for this project. And this is the project name, which is the off-grid photovoltaic system for Mr. Ahmad Nifu Residential House, and for the site file and also the material file, which is shows at the Taman Sri Pura Belana, Johor Bahru, Johor, at the Malaysia. And this is the residential house for the Mr. Ahmad Nifu. And in this, we are going to setting for the geographical site parameter, which are the latitude, longitude, altitude, and also the time zone at this area. And after setting this for the location and also the material, and we can going to set for the main parameters, which are the orientation. And in this orientation, the field type is set to fixed tilted plane, and for the plane tail is for the 30-degree, and for the azimuth is 0-degree, as shown in here. And this is for the optimization with respect to the yearly irradiation year. And this shows that for the plane tail is at the 30-degree, and for the plane orientation is at the 0-degree. And next we will click the OK, and next we can proceed to the user's need. And in this user needs, this shows that the daily household consumption for the Mr. Ahmad Nifu residential house. And for the daily consumption, they have used the lamps, which is in 5. And for the lamp, for the power is 65 watt per one lamp, and for is used for 10 hours per day. And for the TV have 2, and the power is 100 watt per one appliance. And for the air conditioner have 3, and for the power is 950 watt per one appliance. And for the fridge or the refrigerator have 1, and is 15.6 kilowatt hour per day. And for the washing machine have 1 is the 3000 watt average. And for the laptop or the modem have 2, which are the 200 watt per one appliance. And for the fan we have 5, which are 60 watt per one appliance. And next we can go to the hourly distribution. And in this hourly distribution, we can see that for the lamp used for the Mr. Ahmad Nifu house is used and also operate starting from the 7 p.m. until the 5 a.m. While for the TV is operate in 3 hours, which are from the 6 p.m. to 9 p.m. And the air conditioner is operate at the 8 hour. And also for the fridge is operate 24 hour per daily, and for the washing machine is operate for 2 hours, while for the laptop or modem it's operate for 8 hours, and the fan is operate 8 hours. And next we can click the OK, and next we can go to the system, and we are going to setting in this system, which are enter the accepted PLOL is the probability of loss of the loads, which is set to the 5%, and the requested autonomy is set to 4 days, means that if the sun is not available. And for the battery voltage is 96 volt. And in this storage for the set specific for the battery set, and we are going to use for the 12 volt 296 Ah, means that 296 amp hours, which is use the PV cell plates, which is tell CF11 PS. And this means that the how many amps there will be, the battery will be delivered in 1 hour. And after setting this, and we can get that we need the 8 batteries in the series and also 8 batteries in the parallel. And the number of battery we use is 64, and the number of elements is 384. And we'll go to the PV array. And in this PV array, we are going to setting for the PV module. We set to the old modules, and we choose the 320 WP31 volt for this. And next, we use the control mode and also the controller, which is set to the MPPT converter, and this is the converter that we use. And next we will use the number of module and strings, which is in 4 and also in the 13 for the number of strings. And this is the 52 area, which is 101 meter squared for that area for the Mr. Ahmad Nifu residential house. Next we can click the OK, and next we can run the simulation, and we can see that the designing for the off-grid photovoltaic system for Mr. Ahmad Nifu residential house. And we can click the report, and it will generate the document that we have set for just now. And we can observe and also get all the data from the photovoltaic system. And this is the simulation report for standalone system for Mr. Ahmad Nifu residential house. And we can see that for the project summary, that this is for the geographical site parameter for the latitude, longitude, altitude, and also the time zone for Mr. Ahmad Nifu residential house area. And this is for the system summary that we have set for just now. And this is for the general parameters with the battery and also the PV array. And this is the new shadings parameter, which is perspective of the photovoltaic field and surrounding shading scheme that we are going to designing for Mr. Ahmad Nifu residential house. And next we can see that for the detailed users need, starting from the January to the December, that we have setting based on the requirements from the Mr. Ahmad Nifu. And next we can see that for the managed results that we get starting from the January to the December, and we can see that all of the parameters and also the results. And this is for the loss diagram. And from this loss diagram we can see that the loss which are for such as for the battery efficiency loss, and also the for the current efficiency loss, and also for in the battery store energy balance, and also for the converter loss. And this is for the spatial graph, as this is used for the daily input and also the output diagram that used for the effective energy in kilowatt hour per daily. And this is the designing for the off-grid photovoltaic system for Mr. Ahmad Nifu residential house. Thank you.
My name is Ifan, AE1900077. Today I'm doing a presentation on PV system, solar system generation for the Mr. Ahmad Nifu. So I'm from group 3, section 6. So I'm going to use this spec. There's a MPPT controller inverter and a PV module selection of a series. So these are the series that we have selected for our battery set and a PV array. So I'm going to show you the manual approach. First, we're going to have a detailed user needs. So the location of the Mr. Ahmad Nifu is at a Taman Sri Pulau Perdana. So I'm going to have a 48k kilowatts hour per day for the user needs according to his conditions. And we're going to have 365 days of conversion from per day to the per year units. So I'm going to have 17k kilowatt hour. So the produced energy that we'll suggest is 18 to 20k. So the lost energy will be around 1 kilowatts per year, because due to the conversion loss and the battery and systems. So our PV system characteristic, we are using this battery pack, battery series PV module controller, and autonomy, which means no sunlight at all, will be 4 days. Okay. For the calculations that I'm going to show you is using a 320 watt power of a solar panel with 52 units. So I'm going to have this power generation, 16.64 kilowatts power. So I'm going to set a 3 hours of irradiance peak at a Mr. Nasu residential house. So this is based on assumption, and it will be 49.92 kilowatts hour per day based on the 3 hours irradiance. So for my battery pack, I have 4 days. So I'm going to have calculate the user needs, which 4 days I'm going to sustain it. So the original is 193k kilowatt hour of a 4-day sustainability. So I'm going to put an allowance of 10-20%. So the ideal battery pack will be 200k something, okay, within the 4 days. So I'm going to, because Mr. Nasu is 48k, he's going to use 48k per day. So with a 10 to 20 allowance is much better for him, because there will be loss in the system generation, the efficiency, and the depth charge of the battery. So for our battery chosen is a 12CF11PS, so it's a 12V 296 Ah. The energy storage is just based on 12V and times the 296, we get this watt hour. It is a per unit calculation. So we're going to store this amount of value, 200 something. So I'm going to divide this into per unit, and I'm going to get my assumptions of 60 to 66 number of battery needed. Okay, so For our MPPT controller, we have a 96 volt and 1000 watts. So the battery pack is 12V. This is based on my assumption that a 12V is times 8, so I'm going to have an 8 times 8 arrangement of battery. So it's 64 batteries unit. So all of it, I'm going to get this 2068 ampere hour per series. So I'm going to times it again, and I'm going to get this value. Okay. So for the annual power generations, the 3 hours is 49.92 kilowatts for the assumption of irradiance light. So I'm going to calculate it into 317 days because 48 days is totally no sunlight for the autonomy, and which is equal to this amount. So apparently that Mr. Nafsu needs 17K and it's just only 15K because we are just based on the assumption of 3 days. So I've calculated that the release of peak sunlight must be greater than this value, 3.35 hours per day, in order to sustain Mr. Ahmad Nifsu solar power, the solar energy needed. So I would suggest that 20K is better for Mr. Nafsu's situation. Okay, thank you.
Good afternoon. My name is Suzy Sen. My metric number is AE19093. I'm from Group 3 at Section 6. Let me continue the result and discussion. So summary of PV system for recipient Mr. Ahmad Nitful house is shown in figure 1. Table 1 summarize the system performance throughout the years. The annual global horizontal irradiation available is 1639.8 kilowatt hours per meter square, but only 1422.8 kilowatt hours per meter square is effectively available in the PV array plant because of the energy loss. Generally, the system can meet the yearly load demands, which is 17,693 kilowatt hours because the daily demand is 48 kilowatt hours and multiplied by 365 days, which is 1 year. So the estimated value that we get is 17,520 kilowatt hours. However, there is 2,186.5 kilowatt hours of excess 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 energy generated because only 2 months of extra power are not being delivered. For instance, there is no excessive excess energy in July and August with the solar irradiation being equally converted into the energy used as still excessive energy generated in the other 10 months because of solar irradiation is completely excessively than the energy usage. Unfortunately, 687.3 kilowatt hours of energy missing occur due to the reflection loss, resistive loss, recombination loss, and or thermal loss. The occurrence of energy loss will affect the efficiency of the solar cell. For instance, there is a higher of energy missing in June, which is 316.4 kilowatt hours day, and this will decrease in efficiency available in at the solar panels, which is only 88.9 kilowatt hour per meter square. Next, next figure 2 shows normalized production per install kilowatt peak. The dairy supply to the users user to the user is 2.8 kilo hours or kilowatt hours or kilowatt peak. Well, unused daily energy due to the battery full is 0.36 kilowatt hours per kilowatt hour or kilowatt peak. The PV array loss is 0.63 kilowatt hours or kilowatt peak per day, while the system loss and the battery charging are 0.31 kilowatt hours or kilowatt peak per day. The overall performance ratio is as shown in figure 3 is 68.2%. Last but not least, figure 4 summarize the system energy loss throughout the years. The nominal PV array energy at STC is 23,683 kilowatt hours, but only 18,899 kilowatt hours is available as output from it. The loss are due to the PV array, which is 11.27% and unused energy because of the energy full, which is 10.37%. For PV array output, only 17,006 kilowatt hours has been supplied to the user, where the significant losses from converter efficiency, which is 4.83%, and the battery efficiency, which is 7.39%. So this is all for me. Thank you.
Very good morning to all the lecturers who is watching this video presentation now. I'm going to present with you about the group project for BEV30303 in the conclusion part. So, the estimated amount of user demand for the Mr. Ahmad Nefso residential house is 48 kilowatt hours per day. It was being proposed and evaluated by using a PV system simulation. So according to the solar energy resource, the optimum PV array size is 16.64 kWp, while the battery bank size is 2368 Ah at 96 volt. It is designated for 4 days of anatomy, and the system will meet the load demand through a year with a 67.9 performance ratio. So the occurrence of system loss is due to the loss of temperature, converter efficiency, and battery efficiency. And also, the more thing is unused energy because of battery fuel. By referring to the analysis, the proposed design setup is expected to reduce the electricity consumption up to 17,693 kilowatt hours per year and avoid 1.7 tons of carbon emissions into the environment annually. And that's all from the conclusion parts. Thank you very much. Thanks for your attention.